Gradient of a straight line. The gradient of a straight line is defined to be the tangent of the angle that the line makes with the positive direction of the x-axis. That bit there is the most important bit, the positive direction of the x-axis. Well, what does that mean? Okay, so we know that we get, typically you've got two kind of lines here. We've got one that's a positive gradient and one that's a negative gradient, and you should know that from your National 5. Now the positive direction of the x-axis, and this is the key bit that you could potentially get wrong, is this angle here. That angle there is the positive direction of the x-axis going up to the line, which means you would still do that angle to there. Now you're going to see an example later on where this is the trickier one, because, and you'll see an example too. Okay, so, and look, this is look at the equation here, m equals tan theta, n equals tan beta. We really are just want you to remember one, m equals tan theta. You're not given that equation, you need to remember it. So anytime you're talking about gradient and angles, that should be something you've got in your head. Okay. Two examples here. Find the gradient of each of these lines. So I've got two examples. Don't worry, example 5. Got two examples here. Got a positive one and we'll get a negative one. And I'm going to show you how you do both of them. Right, okay. So this one's 60 degrees. Again, like I just done earlier on, we've got this guy here. But more importantly for this guy here, don't forget it's up here. So let's go into this one's the easier one first. Okay. Well, all I'm going to do is, I've got my m equals tan theta, m equals tan 60, and then here you've got the grade m equals 1.7. So the gradient's 1.7. Okay. Pretty straightforward. Next one. So here's this one here. Now I like to always find that angle, and you can tell there's a 180 degree, it's a straight line, so this guy in here must be 140. So m equals tan theta, tan 140, and if you do that in a calculator it will give you the negative 0.8. Okay. Right, I'm going to give you two examples. You can pause them and then you can try them yourself. This example here, that's only one example. And again, look, it's not got a diagram. Calculate the gradient of the straight line ST, which makes an angle of 60 degrees with the positive direction of the x-axis. So 60 degrees. So basically you just do a sketch. 60 degrees. Okay, that's what you've got in your head, right? So that would then trigger you to go straight to the following. And the tan of 60 is root 3, and we'll talk about these values later on in the course. Tan of 60 is root 3 or whatever it is in your calculators, but that's the gradient. Now I want to do one example where it's the other way. It's where you're given the gradient and you need to get back to the angle, and this is quite important. This is more like an exam question. Okay, in this one here, calculate the angle theta that the line with the gradient minus 5 over 2 meets with the positive direction of the x-axis. Now, you know you're going to use n equals tan theta. Okay, so I'm going to step through, you'll see the answers coming up. The SQ are quite particular how this is laid out, and some kids kind of mix it up. Really stick to how the approach is done here. So, we know we're going to use, look, so they've changed it, tan theta equals m, the same as m equals tan theta. Next bit, so we'll get to there, tan theta equals minus 5 over 2, and that's really important. The gradient is negative, so we should expect an obtuse angle. Okay, that's really important. So you get the negative on your diagram, it will be the obtuse angle. So you do 180 take away, so if you do 5 over 2, you're going to get the 68.2. So 180 take away 68.2 equals 111.8. Now let me show you how you do that on a calculator. So shift tan, I do 5 divided by 2, and I get 68.19. But remember, that's the acute angle, so you would need to take that away from 180 to get the obtuse angle. Okay, so you take that away, so that's what's happening now. Okay. Now, interestingly, if you've done this, shift tan minus 5 divided by 2 is the bracket. And that's going to really be weird, right? So you try not to get confused with the triangle, because some kids might think that gives the answer. Okay, so that's the approach there. Okay, so I'm doing exactly what I would do normally if I was teaching these guys. You've read the comments at the beginning of the assignment. So typically what I'm doing you do a couple of easy questions like this up here, which I've just covered, right? But I'm aware that at the end of the day, they're not going to be in the exam. What's going to be in the exam is this kind of stuff. So I've got 2 more questions to do. This is a really important topic. This always comes up in the exam, and a lot of kids screw this up. So I think if you just get your head right, you'll be fine. So let's go and do this one. Find the gradient of the line joining the points minus 2, 4, b minus 6, minus 2, and hence find the angle that this line makes with the positive direction of the x-axis. So there you've got, it's about line, right? So it's line, and it's angle. So you know you're going to use your m equals tan theta, but you haven't got your gradient or your angle yet. So, but I know it's a line between 2 points. So right away I'm going to get my gradient, and I'm going to use my skill, using y2 minus y1 over x2 minus x1 to get my gradient, and then I can use m tan theta. Okay, so if you want to pause it and try and do it, pause it now and get to work on it, and then you can go back and check this out. So what we're looking to get, so there's the gradient coming in, and I've got minus 6 over 4, minus 6 over minus 4, 3 over 2. You make sure this all gets tidied up, nice and simple. And then I'm going to go here, look, tan theta equals m, tan theta equals 3 over 2. And because it's not negative, right, it's the acute angle. Okay, now that's 3 marks in the exam. Okay, next one. Find the gradient of the line joining the points minus 6, 3, 4, minus 1, and hence find the angle the line makes with a positive direction of the x-axis. Okay, so this might be the slightly trickier one. Pause it, give it a go. Okay, so what do we do in this one? Well, I need to go over the page, so I'll pause. So what we've done was we've done the gradient equation, and we got it down to minus 2 over 5. That should be a trigger when you're using m tan theta, that you're going to do the 180 take away that acute angle. So you do m, tan theta equals m, minus 2 over 5, and there's your 180 take away your 21.8 when you've done 2 over 5 in your calculator, and you get 158.2. So you've just done quite a hard question you haven't got a diagram for. Okay, so I think I've covered m equals tan theta. Go away and work on the exercise attached. Okay, thank you.